Have you ever wondered why exam score, human height, and even measurement error follow the same bell-shaped curve? This is not a coincidence. This is the power of normal distribution, and the normal distribution is one of the most beautiful and universal pattern in statistics and probability. Hello everyone, I am Bindeshwar and I am going to explain normal distribution step by step. So without further delay, let's get started. So without moving to normal distribution, just understand, again recall, I have explained it. What is a random variable? And there are two types of random variables. The first one is discrete random variable, and I have explained like binomial distribution, Bernoulli distribution, Poisson, hypergeometric, geometric, and negative binomial. These are most important discrete distributions, and you might have seen that random variable x was taking discrete values. Now we will move to learn about continuous distributions, but we have to know about continuous random variable. So a continuous random variable takes any value in the interval of real numbers, that means minus infinity to plus infinity, and it may be 1.5, 0.5, like this one. Instead, like discrete random variable was not taking this kind of number. Discrete random variable was being started from 0, thereafter 1, none in between, 1, 2, 3, like this. So these are discrete numbers, but continuous random variable, it can take all values. Now in this section we will focus on continuous random variable and the most important one, normal distribution. As I might have explained that normal distribution, you can say that hidden engine of AI and artificial machine learning. So that's distribution is very important. In statistics, probability distribution, machine learning, generative AI, and deep learning. In all cases, it must be applied somewhere. So just I am going to explain a random variable x, as I have already written, is said to be continuous if it can take any real value. In interval or whole interval, and its probability is described by probability density function. So here you need to know, for a discrete we use the term probability mass function, but for continuous we will use probability density function. So normal distribution will have probability density function, but binomial, Poisson, negative binomial, hypergeometric, geometric, Bernoulli, these will have probability mass function, and normal distribution will have probability density function. And we will know that probability that x lies between a and b, that would be from integration from a to b. If for a discrete case we were using summation, but for the continuous case we will use integration. And the total area under curve, that will always be 1, because this would be the sum of all probabilities. Now the most common continuous distribution, that is normal distribution, and I have also started from this one. There are also like beta, gamma, and it has second kind, first kind, exponential distribution, but normal distribution is the most important, and I have started from, others are also very important. So a continuous random variable, let us see, x follows a normal distribution with mean, mu and variance, that is sigma square if it's PDF. See that 1 upon sigma variance under root 2 pi e raise x minus mu whole square upon 2 sigma square, that is the variance. And where x lies from minus infinity to plus infinity, means whole real numbers domain. This you can say that formula or probability density function you must know, not remember, but you must know each part. And basically it is denoted as x is following normal distribution with parameters mu and sigma square, means mean and variance, that is variance and that is mean. The curve is symmetric, I will show you, and the spread which depends on standard deviation and the standard normal distribution, that is just transformation of x when you subtract mean and divide it by standard deviation, and that will follow into 0 and 1. That means that is mean 0 and that is the variance, where means a distribution having mean 0 and variance 1, that would be standard normal distribution, and the variable following that distribution is denoted z. And if you transform, like if you put z is equal to x minus mu on sigma, so you will see that if you put in the formula, so e raise square upon 2, here there will not be sigma, so that this you can say the density function will transform into this form if you plug this one or put this one, and that is the most commonly used. I will explain the reason why this is used. And mean expected value of random variable x, that would be mu, and the variance, that is sigma square, and shape, that is the bell shaped and symmetric. And see that skewness of normal distribution is 0. In descriptive statistics I have explained skewness and kurtosis, so skewness would be 0. And see that the very nice property that mean, median and mode will coincide. And you know that what does it mean? That means it is symmetric, as I have explained. Curve is symmetric or distribution is symmetric. Area under the curve is 1 because this is probability distribution, probability density function. And empirical rule, see that here. I will show in 60%, 68%, 68.27% will fall within one standard deviation area, 95.45% 2 standard deviation area, and 3 standard deviation area 99.73. See the curve, thereafter everything would be clear here. That means 1 standard deviation here 68, thereafter this one 2 standard and 3, this one in 3 almost 99%. So the grey line marks position of the standard deviations from the mean, and these are about 68%, 95% and 99.7 of the data lie within 1 standard deviation, 2 and 3 standard deviation distances. So there are many applications. It is used in natural and social sciences to represent real valued random variables. That is commonly applied in measurement errors, heights, widths, blood pressure, quality control and industrial process, finance, like risk modeling and the central limit theorem state that the sum of many independent random variables tends to normal distribution instead of underlying distribution. That property is very important. Central limit theorem I will explain in the next video. And see that apart from this, normal distribution is used in generative AI, machine learning. Linear regression is completely based on normal distribution. Diffusion models of generative AI, that is, you can say that that's use completely normal distribution. Variational autoencoders, that algorithm uses normal distribution. Like other linear discriminant analysis, Gaussian naive Bayes, there is a list. Apart from these things, I'm just talking about machine learning and artificial intelligence. So you can understand how normal distribution is very important. So you will see that at good universities, they teach normal distribution. And they also explain in detail. That means other distribution too, but they will focus because that tells the pattern of data. And pattern of data is everything in AI and machine learning and generative AI. That shows the universal pattern of data. So you can understand. So hope you understood. So I will tell you if you understood and if you like my videos. So please subscribe, visit website sometime. Also visit Facebook page, LinkedIn page. Also visit GitHub repositories where I upload whatever I have made code related to LaTeX, Menim, and many you can say that real life applicable code I upload also from PyTorch. So you can visit and you can understand. You can also suggest me something to do new. So hope you understood. Thanks for watching the video.